Hello everyone, my name is Michael Steinhardt. I'm the tech editor here at CBS Interactive, and we're proud to present Continuous Delivery in the Enterprise, a live and interactive webcast sponsored by Puppet Labs, where we're talking about an issue that's important for every enterprise, changes in the software development paradigms and how they affect your operations. We're going to discuss what's different about today's dev environments, how to iterate and update quickly, and how to gather and implement feedback effectively without bogging down the process. To do that, we have a stellar lineup of experts. Jeff Cogswell is a software development guru, and Carl Kalm is Senior Technical Marketing Manager at Puppet Labs. So let me give you a quick background on our speakers. Jeff Cogswell is a software developer with 25 years of experience. He's written a dozen books and hundreds of articles about computer programming and technologies. He's worked in several industries, including doing C++ programming for telecommunications software, all the way up to modern web applications with JavaScript and HTML5. Over the past 5 years, he's immersed himself in cloud technologies, programming and administering private clouds and public cloud resources. Carl Kalm guides technical and strategic details for partner integrations at Puppet Labs. He's also served as prototyping, team lead, product owner, and solutions engineer. His background is in systems administration and software development. So before I turn things over to Jeff and Carl, I want to remind everybody that today's presentation is fully interactive. So first and foremost, you can submit your questions using the Q&A button on your console, and our presenters will do their best to answer that during a Q&A portion at the end of the webcast. And we're also going to turn the tables and ask you questions in the form of audience polls that we're going to push out during the webcast, so keep an eye out for those. If you'd like more information about Puppet Labs or you'd like to download this presentation, please refer to the Related Resources widget, which is also on your viewing console. Last but not least, if you'd like to refer a friend, this presentation will be available on demand within the next 48 hours, and you can review it, you can push it out to friends, share it, and continue the conversation. With that, I'm going to turn things over to Jeff.
Great, thank you very much. So it's good to be here, and what I'm going to do is talk a little bit about the way software used to be. So let me advance to this next slide here. Michael, I'm not getting a next slide, so could you advance them for me, please?
No problem.
There we go. Great. Great. Excellent. So I'm going to talk about the way the software used to be back in the old days, back when I first started out, and then briefly how things have changed. So the old days of software were basically boxed software packages where we would release a new version every 2 or 3 years, and we would send it out in a box, and people would go to the store, to the mall, to the software stores to buy the software, or we would ship them out and for the pre-orders, and that worked pretty well for the times. Next slide, please. And we would have feedback from our companies and from our customers, and the responses were pretty slow though. We would get feature requests, but the problem there was new features were already underway. We would definitely listen to their requests and try to work them in, but by the time we would release a version, which we called Going Gold, was when we released it, we had pretty much already decided on the new features for the next version. And now remember, these releases weren't coming out for every 2 or 3 years. So what that meant is, let's say it's January of 2015 and we release our new version. By then we've pretty much put all the features for the next version, which will come out January of 2017. So right now, if you have a feature request, well, we'll fit it in January of 2019. So we're talking 4 years down the road. Next slide, please. And that meant basically allowed us to do slow builds. Features took weeks to add, often even months to add, and we would really stretch out everything that was happening. But the problem there is if we had big clients, big corporate clients, they couldn't really check in on us. They couldn't see how things were going. It's kind of like if we were a car repair shop and we wanted to upgrade the transmission. We take apart the car, and while the car's apart, well, you can't drive the car. Well, same thing here with our software. We couldn't demonstrate the software very often. So if a client wanted to come in, we would have to provide a very controlled situation. We couldn't let them just drop in on us. We would have to set up a computer in a specific room and put a very specific build on that computer. And typically, we could only demonstrate the features that we planned to, because everything else was usually broken. It didn't run. And so as the two-year span would get closer to the release, we would start to piece everything together, and gradually the thing would come into view and into being. And that worked great for the times. Next slide, Michael, please. But now we're in a new world of apps where customers pretty much demand that their feedback be answered and often implemented, and not just 2 or 4 years down the road, but pretty quickly. They want to see responses now. Next slide, thank you. And so in today's world, we need to embrace a different way. This means that software development world needs to operate differently if we want to succeed. Releases have to come out much more often, possibly even as much as once a month. If you wait a year, people are going to assume that you've actually abandoned your product, and they'll go with the competition. So what that means is we need new ways, we need to embrace these new ways of getting feedback quickly, such as through the app stores and through the reviews, and embrace new tools and methodologies. And that needs a new tool, a new way of thinking called continuous delivery. Next slide, please. And this is where Puppet Labs comes in. They use familiar tools such as version control, but it's in a modern setting. And we use new strategies for competitive advantages so that we can respond to market demands more quickly. And so with that, let's hear from Carl Kalm of Puppet Labs.
Great, thanks, Jeff. Just a couple of things here. Molly, can you hit it on slide 10, please? Okay, great. A couple of housekeeping items. We are going to be recording this session, as mentioned earlier, and we'll make sure that gets out to everyone. And go ahead and submit any questions that you have as we're talking to the Q&A, and we'll address those at the end. So next thing we want to talk about is, whoever's, I need on slide 11, whoever's got control of that. Sorry, we're having a little technical difficulties with the slides. There we go. All right, great. The one that said don't work is the one we needed. Michael, can you put that on slide 11, please?
Absolutely. Sorry about that.
All right, there we go. Thank you. All right, great. So if you look at in history of systems administration, you see a world of manual configuration, of custom scripts, golden images, legacy tools, and really the legacy tools, all they did is help you manage your golden images and custom scripts and help you do manual configuration. So tools like Cluster SSH comes to mind, Bash scripts comes to mind. When virtualization became prevalent, people started packaging their configurations into golden images. But all that ends up doing is creating a series of black boxes. Your templates, you have no idea what's in them. Maybe you give them a version number and you document it in a Word document, but that doesn't really tell you about the configuration of that template. Likewise with custom scripts, if you look at a Bash script, Bash is a true programming language. It may not be as advanced as some of the higher level programming languages, but it is a programming language nonetheless. So when you go to do the tasks that you need to do on a system, there are literally millions of ways that you can do that, and that actually creates a problem because that means that the script that you write is very difficult to maintain for somebody else. And getting the exact behaviors that you want out of that Bash script is very, very difficult. So, for example, knowing where it failed, why it failed, getting all the reports out of it that you possibly can, getting all that data is exceptionally difficult. Manual configurations are very difficult when you log into a box and you ended up creating a box where you don't understand what's actually on it in the history of that box. So we need a new world. So if we can go to the next slide, please. Yeah, so we had a poll question coming up. Michael, I think that was on slide 12 was the poll question.
All right. Sorry about that. Here's a question that we have For the audience, please pay attention to your console and answer it as it comes up. The question is, how do you deploy Puppet code to your Puppet masters? You have 5 choices. R10K, custom scripts, manually, other, or I don't use Puppet. So please take a moment to select an answer. As we mentioned, you can use the Q&A button to ask us questions as we ask you questions. And Carl and Jeff and I will take a look at the results a little bit later on in the program. In the meantime, I'm going to advance to Carl's next slide. Please go ahead.
Thank you very much. So yeah, we need a new world. We need a way of being able to talk about the configurations of our systems and be able to trust that what we're doing is working, is going to work, first of all, understand what work is being done, and trust that the work that we want to do is going to happen in the way that we expect. So basically, we need automation. That is something that Puppet Labs has really specialized in and really taken hold of. Can you go to the next slide, please? Thank you. So how Puppet works is we believe that all of your configuration on your systems can be broken down into core resources, whether that resource is a user, a group, a DNS entry, a kernel setting, maybe a mount point, anything that you can talk about as a single entity, as a single instance, and that has attributes. So if you look at a user, it has a password, a home directory, a UID. A mount point is obviously going to have a source and a destination. We can talk about files, services, packages, and be able to group those things together. So what Puppet does is it takes these resources and allows you to describe the desired state of those resources and what you want them to look like. And when Puppet runs, it's going to compare the actual state of the system to what you said the state should be. And if there's any difference, we're going to fix that. Now that allows you to treat all these different resources, whether they're groups, users, packages, firewall rules, and treat them as Lego blocks. Now we can start to stack our Lego blocks together and know that whenever Puppet runs, we are going to compare the actual state and make sure that it's always in the desired state that we want it to be, using these Lego blocks as pieces. Next slide, please. And so that is how we kind of think about it, is we don't want to talk about what needs to be done, but rather what we want it to look like. So we define what we want our desired configuration to be. What should our systems look like? Not how we're going to get there, but what are they going to look like? And then Puppet will take that definition, compare the state of what state the systems are actually in, and any changes that need to be made will be made. Now that means that if you think about it from a provisioning standpoint, you can take a virtual machine, brand new operating system on it, just the operating system and just Puppet. And when Puppet runs, well, practically everything's going to be out of the desired state. So it's going to provision everything. It's going to configure everything and have you a fully functional system within minutes. Further, Puppet will keep it that way over time. Now that system is no longer a black box. Now you know exactly what was configured, when it was configured, why it was configured, and how it changed over time. Next slide, please. The advantages of being able to do that are obvious. When you look at the advantages of automation, you can talk about speed is an obvious one. I just talked about provisioning a VM within minutes. I've talked to some firms who take literally weeks, maybe even months at times, to be able to fully configure a virtual machine because of all the tickets that have to be handed off, all the different priorities that have to be managed, all the different manual tasks that have to be done, all the tickets have to go in when something wasn't configured correctly. Well, with Puppet, you define all of that up front, and so it just takes minutes to complete. That gives you really fast cycle times. That means that we can take an idea and we can get it out there as fast as possible. But I want to stress the cycle time part. That means that we can have a cadence of release. We don't just have one win. We don't have 2 wins. We have a cadence of wins. We can define something, get it out as quickly as possible, and do it over and over and over again. That obviously leads to productivity. We can define something once. We can do that repeatably, but we can also do it across thousands and thousands of systems. So if you look at just one virtual machine that we automated and we can configure it within minutes, well, now we can take that exact same work and do it across thousands of systems. One of the great things about the declarative idempotent way that Puppet works, idempotency meaning that you can run something over and over and over again and each time get the exact same result, which is something, by the way, you cannot do with Bash. It's exceedingly difficult. Is you get a lot. The advantage of that, you get a lot of insights. It means that we always know the exact state of our machines because Puppet is going to run. It's going to make sure that it's in the desired state that we want it to be in, and it's going to tell us what happened during the run. Hopefully nothing. Hopefully nothing was necessary. All right, next slide, please. So let's talk about how this relates to continuous delivery. A lot of people, I just want to get this out of the way in the beginning, a lot of people think about continuous delivery as I make a change to my code, and that change gets to our customers just ASAP. It's just get it to them within minutes. But that's not really what it is. Our goal is to prove that every change is deployable at any time. And the reason I stress this is that deployments should not be a technical limitation. When you deploy should not be a limitation of IT, but rather a business limitation. You ship when the business is ready, not when IT can. So we're going to remove IT from being a blocker, from being a limitation, and instead say that we are going to implement continuous delivery to show that every change that we make to the code is deployable to production to our customers at any moment when the business is ready. Next slide, please. So continuous delivery is the natural next step of continuous integration. Continuous integration ushered in a brand new world for development. The problem is continuous integration was a siloed optimization. It made development in QA significantly faster, but it didn't make anything else faster. And if you look at the development, the product cycle process, there's a lot more to the product than just developing it, than just the development piece. There's the deployment, obviously. There's the monitoring. But I'm focused on heavily on the other side of it, which is the product management side. You have to be able to optimize the entire process, not just one single silo. So if you look at continuous integration, it ensured that every change works with every other component of the application. Great. Does that show that it will work in production? We don't know that. We didn't put it behind a load balancer and configure it the exact same way with the exact same routes and the exact same firewall rules that we're going to have in production. It provides rapid feedback of application functionality, but does it show that it will scale to what's going to happen in production? Most importantly, the most important thing about continuous integration, at least from my perspective, looking at the entire process, is it produces an artifact that is intended for production. Great. Does that actually install on a production-like system? Next slide, please. So with continuous delivery, we want every change to be tested in a production-like environment to provide confidence. This is about confidence. We want to be able to track customer value that has been prioritized from product management and be able to define that in UX and design and build it, actually build something, put it into a continuous integration to produce an artifact, and then deliver that artifact as soon as it's ready to a production-like environment, showing that we have confidence that we can hit the button and push that out to our customers as soon as possible, or as soon as we're ready. All right, next slide, we've got a poll question.
All right, thank you very much, Carl. Next question for the audience. Is continuous delivery a priority for your business in 2015? So your choices are yes, it's a high priority. Yes, it's one of our highest priorities. You can choose it's a medium priority, low priority, or not a priority at all. So please take a moment to make your selection. And as I mentioned, we're going to come back and take a look at the results later on in the program. And I'll also remind you that you can download the slides and learn more about Puppet Labs by checking out the related resources widget in your console. With that, I'll turn things back over to Carl.
Thank you. Great. So configuration management plays a very important role in all of this. When we are going to be defining our infrastructure with configuration management, we can obviously use that to deploy the applications that we're developing on the continuous integration side. We can take that artifact, apply our configuration management to it in a production-like environment and staging, and show that the configuration management code is going to be able to deploy that artifact to production, or at least have exceptionally high confidence that it will. So the rules of staging, no humans. Everything is code. Get it as automated as you possibly can. Everything needs to be reproducible. Everything needs to be stateful, meaning that you should be able to introspect your staging environment and understand what state it's in and what state you desire it to be in, so that you understand that you can go from where it is to where you want to be. That means that when you apply your code, you can run it in production and have full confidence. Infrastructure of code is obviously very critical to all of this. And by far, if you're going to take anything away from this slide, take away version control. You've got to version control every single thing you do, whether it's your artifact, whether it's your infrastructure as code, whether it's your development code. Everything must be version controlled. Next slide, please. So there's the part of continuous delivery that is we want to give value to our customers, and that's very important, but there's also something else to it. Every single infrastructure change that you make is a chance for service disruption. It's a chance for downtime. 70% of all downtime is caused by misconfiguration. That equates to $2.5 billion to the Fortune 1000. Not only does that mean that your customer is going to leave, but downtime is simply money. This is money in your pocket. It's not just about improving your customers' lives and just about improving your admins' lives and your developers' lives. This is actual downtime equals money. So we need to be able to improve that as well by using infrastructure as code, by using automation, by using a staging environment and continuously delivering to it. We can have much more confidence that we can reduce downtime because we have much more confidence in the work that is going to be done when it gets to production. Next slide.
All right, looks like we have one more poll for the audience. This question is, how do you package your applications? 4 choices. You can choose tarballs, version control checkout, OS packages, or containers. Please take a moment to make your selection. And as you do that, we will continue the conversation, turning things back to Carl.
All right, so how do we actually do all of this? Now that we know it is important, we know why it's important, we all want the same thing. We have to get to continuous delivery. How do we do it? So the first, we're going to show lots of technologies in our demo today. The first thing we're going to focus on is Puppet modules. Puppet modules is a way of packaging all of the Puppet code that is going to deploy a thing, whether that thing is SSH, NTP, Apache, WordPress, anything that you can talk about as a single piece of an application or a single piece of a service or configuration, you can package that within modules, and modules are reusable. We can download them from the Forge, we can write them ourselves, we can share them between teams, and it's all self-contained. We're also going to use Jenkins Enterprise. Many of you are probably familiar with Jenkins, so I won't go into too much detail. The Enterprise feature has some really great RBAC functionality and workflow support that makes continuous delivery a lot easier, so you can see the whole pipeline. We're also going to be using Beaker. I'll talk about Beaker quite a bit later and show it to you, but it's an acceptance test framework for the Puppet modules, so that when you make a change to your Puppet modules, you can have confidence that the change you made didn't break something else. We're also going to talk about Puppet Code Manager. The problem with having infrastructure as code is that now that you've got all this stuff automated with code, great, it's all version controlled, how do you get that process from keyboard to production? Puppet Code Manager is our tool for helping you do that. It's still in its infancy. We just released our first version of it, and we'll be talking about a tool called R10K that is our first component of Puppet Code Manager. We'll show that to you later. We're also going to be using a tool called mCollective, which is developed by Puppet Labs. mCollective is a command and control system. It's a way for you to take a command and push it out to thousands of systems all at once and get results on the results. So you can think of it as kind of like cluster management, but basically being able to do an ad hoc task across a collection of systems. Next slide, please. So I want to talk to you very briefly before we go into the demo about the roles and profiles pattern, because it's very, very critical. We have found at Puppet Labs that this is one of the biggest the best practices patterns to follow when you're developing your infrastructure as code. If you go to the Forge, you can see thousands, over 3,000 actually, Puppet modules available for you to download. What we have found is that people have most success when they use those as core modules to manage things like SSH, NTP, WordPress, but then be able to group different core modules together into profiles. So, for example, we may have a profile that manages our application, and then another profile that manages the network components of our infrastructure, another profile that manages just the firewall rules, and then take all of those profiles that we're going to mix and match onto a system Whether it's a database server with a bunch of core infrastructure configurations or a WordPress server with a bunch of core infrastructure components, and put all those together into a single
Right,
role.
so in the slides earlier, I was showing you different technologies that we're going to piece together in order to create our continuous delivery pipeline. The first technology we're going to talk about is the Puppet module. Currently, I am in a Puppet module called the CloudBees profile module, and if I look at the files in here, the most important one that we see is this manifest directory. That manifest directory contains all of our Puppet code.
With all of that, let's get to the demo.
If we go into it, we can see all of the profiles that we have set available for our environment. Now, when I was talking about the roles and profiles relationship, these are the things that get rolled into our roles. The roles gets assigned to the individual nodes. If we take a look at our roles module, which is right over here, we can see, again, in our manifest directory, all the roles that we have available for this demo. We have a demo role, we have a Jenkins Enterprise role, and a PE master. Let's take a look at the demo role. In here, we're just defining a Puppet class called role demo, and we're going to pull in a bunch of profiles. Down here, we're explaining the relationship between two profiles that have a relationship, which is the database and the web component. As you can imagine, we want to make sure that the database component is enforced before the web. But we're also going to pull in some common profiles. We're also going to pull in a PE environment and set some firewall stuff, things like that, common infrastructure configuration. And if we go over to our profile, we can see that we have our corresponding profiles right over here. If we pull up common, for example, we can see that for Red Hat, we're going to pull in EPEL and then not do anything with anything else. But if we pull up our firewall profile, we can see that for Linux, we want to make sure that we purge any firewall rule that is not being managed by Puppet. But more importantly, if you go into the demo directory, you can see that we have our DB and our web profiles that we saw in the role. We pull up our DB profile. It's very simple. We're simply saying that we have an installed directory of opt WordPress by default, and we're going to call out to Hira to get our default database user if one isn't specified with the declaration of this profile. And the same thing for the password. I'll show you what Hira is in a minute, but the important thing down here is that we're going to include the MySQL Server class. Now, this MySQL Server class is provided by the MySQL module, which I did not write. This is a module that we pulled down from the Forge. The Forge has reusable modules that we can download and use, usually in profiles, and kind of wrap them together to be able to manage our common infrastructure in our environments. We can take a look at the MySQL module. Here, it's written by Puppet Labs and is PE supported, meaning that if you're a Puppet Enterprise customer, it is fully supported, fully tested with all of the Puppet Enterprise versions. You know it's going to work, and you can call us if it doesn't. If we pull up our web profile, you can see that we're doing something very similar. We're grabbing our database user and a database password, and we're pulling in our MySQL client again from the MySQL module. We're also going to declare the Apache class. Now, the Apache class, again, is from an Apache module that I did not write. It's another Puppet Lab supported module that we can use to just download and use in a profile similar to this and know that Apache is going to be managed correctly. So we're going to set a vhost. We're going to set Apache to listen on port 80. We're also going to set some bindings for MySQL, which is going to be necessary to interface in with WordPress. And we are going to declare WordPress right here in order to get that WordPress application installed. Now, this is from a WordPress module also off the Forge, not written by Puppet Labs, so we can also pull modules contributed by the community and reuse them in our environment. Now, let's say that we want to make a change. We as an organization have decided that we are no longer going to use Apache. In order for our web server, we're going to use Nginx. Lots of reasons we may want to make this decision, but most likely just because we want to standardize on one technology, which means that we have to now modify this profile to use Nginx instead of Apache. Now that means that we need to have a development environment where we get to work on this and try and make this change. So one of the tools that we're going to use now is called Vagrant. If you look, we have this Vagrant file here. And what it does is it specifies a virtual machine that will allow us to give us a development environment local to our laptop to experiment and do the work to swap out Apache for Nginx. And you can see here what we're doing is we're just pulling down a CentOS image. And we're setting the current directory that we're in to Etsy Puppet Modules profile, which you'll see why we're doing that in a minute. And then just clearing any IP tables rules. This is a custom script that will look at all of the metadata for my module and install any dependencies that we have. To give you just a very quick look at that, the details don't really matter as much, but our metadata.json file contains all of the modules that this profile module uses in order to do its work. So what I'm going to do now is simply do a vagrant up. And what this is going to do is pull down the virtual machine image and create a new virtual machine. I'm using VMware Fusion for this, but you could just as easily use something like VirtualBox or even AWS or vSphere. All right, so our virtual machine is up and running. We can see that we have this one little error. And what this is basically saying is that I had tried to install a module twice. So it says that this module already exists on the virtual machine. So I'm just going to go ahead and ignore that error because if it's already there, we know it'll work. And if I do a vagrant SSH, that will gain me access to the virtual machine that I just created. And I can do a sudo su to get to root. Now, if I go into Etsy Puppet, and I go into the modules directory, we can see all the modules that were installed as a dependency of the profile module. We can see that we have our Apache module and our MySQL, which are some that we know that we pulled in, as well as the WordPress. But of interest is the profile module. That's the one that we actually want to do work on. So if we go in here, we see that we have a tests directory. Now, the tests directory, all this does is it specifies a way of instantiating or declaring the classes in order to apply a configuration. So if I pull up this test here, all this is doing is saying I want to declare the profile demo DB class, and here are some class parameters to pass in. This is the DB user and password parameters that we saw earlier. This means that I can do a local Puppet apply on it. I can do a Puppet apply on the DB. And we can see that it's actually going to run this code and apply this configuration to the virtual machine that we're currently on. Now, we're able to do this. This is one of the great features of Puppet. We're able to do this without the use of a Puppet master. This is all done locally on the virtual machine that we spun up on our laptop. And we know that this code will be portable so that when we get it somewhere else, it should be able to work just fine. So now that I've applied the DB, I'm also going to go ahead and apply the web. But we can see here that we installed the MySQL Server package. We went ahead and set up the configuration file and got the service running. And now we're going to go ahead and set up all of the WordPress instances and dependencies. Now, as I'm sure you're aware, Puppet is idempotent, which means that if I run this again, Puppet is going to compare the actual state of the system to the state that I said it should be in. And hopefully nothing will happen. We got some warnings here because we're not using Hira, and it's looking for Hira, but that's perfectly okay. However, nothing was done. No work was done because nothing was necessary to be done. It's already in the state that it should be. So if I get our IP address, I can hop on over to our browser and see that this virtual machine does in fact have the configuration that we want. It's installed WordPress, the WordPress middleware application, and it's set to redirect us to the installer so that we can finish out our work. Now, normally, of course, if you're deploying an actual WordPress site, this would have content in whatever theme or any content that you're using within your corporate application. Now, we want to replace Apache with Nginx. Now, it just so happens I've already done that work, and I'm going to load that up now. I'm going to do a git checkout Nginx. And if you go into here and we look at our web, what we're doing here is we're saying, okay, we know that we have this service Apache HTTPD, and I want to make sure that it's stopped and that it's not set to start on boot. And this is more of a declaration than anything else, just ensuring that this new business policy that we have of not using Apache is continuously enforced by Puppet, that we always know that Apache is not running wherever this code is being applied. We're also going to set up a PHP and, of course, pull in Nginx, set up our vhosts, and then some other Nginx resource location magic. And then the rest was just like it was before. So now if we go back into our virtual machine, again, our declaration, the way we call the class, the way we assign this this profile to a machine hasn't changed at all. It's just the underlying implementation that should change. And if I do apply on this, sorry, that was my mistake. I forgot I have to run vagrant provision on this again so that it will look to the new modules that this module depends on. So pull in the PHP module and the Nginx module. And again, we've already got this module installed, so it's giving us a quick error, but that's perfectly fine. So now that we've run that, if we do an ls on Etsy Puppet modules, we should see that we have the PHP module and the Nginx module. And that was done by me adding that to our dependencies in the metadata.json file. So now, if we apply this code, we can see that we've stopped the Apache service, and we're pulling in our PHP requirements, setting up Nginx. All right, great. And so if I do a service Nginx status, we can see that it is in fact running, and HTTPD is in fact dead. So great. If we go back to our virtual machine here, let me grab the IP one more time. We can see that it is in fact running, and we know it's running on Nginx. Now, what if we want to make sure that every time we make a change, that we know that this isn't being enforced correctly? That's where the tool called Beaker comes in. Beaker is an acceptance test framework for validating the modules that you're writing does the work they're supposed to do on the platforms they're supposed to be applied on. And let me show you what that looks like. If we go back over here, we see that we have a spec directory. And if you're familiar with RSpec at all, this will not seem like magic whatsoever. But if I have the acceptance, go into the acceptance directory, I have this WordPress app spec. What we're going to do here is we're going to describe our profile WordPress DB class, and basically just say we're going to have some Puppet code, and we want to make sure that it applies. So every single time we make a change to our module, we want to run these tests to verify that the change we're making does not break some other functionality of the module or break it on some platform that we were not developing on. It ensures that the module continues to meet all of the business expectations that we have for it, the acceptance criteria, no matter what we're doing to it. So we have our DB being applied here. We're also going to declare our web class. And down here, we're going to actually put in our business logic that says, make sure that it should start the Nginx service. Now, we expect that running service Nginx status will have an exit code of 0. If it has anything else, if it's not running, we know the module does not work. It's doing something it's not supposed to. And of course, we want to make sure that the WordPress application is successfully running. It should respond with a 302 redirect, which is what we can expect here. So once we do a query on it, we want to make sure that we get 302 back, and we get a redirect location to the installer. Now, I am actually going to go ahead and kill this VM because we're done with it. The -f just means go ahead and do it. Don't ask me about it. All right, great. So now that we've done this, I'm going to go ahead and run our acceptance test. And what this is going to do is spin up a brand new virtual machine from scratch and apply the acceptance tests that I was showing you in that WordPress spec file to make sure that all the things that I care about for this module are being applied correctly. All right, so Beaker has finished creating a virtual machine, running our spec tests, and proving that everything works exactly as it should. In fact, it ran our 4 tests, and we got back 0 failures. So great, now we know that this works. So I'm feeling pretty confident about this, and I am going to, I'm going to go ahead and issue a pull request on this. And I'm going to say replace Apache with Nginx. All right, great. So we've got our pull request. I'll go ahead and open this. And we can see all of the changes that we're making here. So here are all of our manifest changes that take out Apache and replace it with Nginx, our module requirements, and our updated tests. So this all looks great, and I'm going to go ahead and merge this. Now, normally in a regular environment, you'd want this to be peer-reviewed. You'd want other people on your team that understand what you're trying to do to verify they're doing it in both the right way and, of course, the best way possible. And this also has a lot of implications for audits as well. So I'm going to go ahead and confirm this. Now, this is where things get a little fun. So if we go to Jenkins, you can see that I have this profile module job. The idea behind this is for every module that you develop in-house, you want to have its own job so that every time you have a merge to master or a new pull request come in, Jenkins will automatically kick off a job to run the acceptance test using Beaker that we just showed you running manually, to do that in an automated way to sign off on the change to make sure that that change works before anything is merged in or just after a merge before it's pulled in by something else. The idea here is that you want to be able to make changes to all of the modules that you develop in-house independently of all the other modules so that you can make changes as fast and as often as you want. Now, in this example, what this job would do is when it's done running Beaker, if everything passed, of course, it would kick off this Puppet site. Now, this is where the magic actually happens. Before I go into that and show you how this works, I want to show you one key component to the Code Manager that I was showing you earlier. Code Manager is our solution for getting code from keyboard to production. This is a problem that we've just now started to tackle in all earnest. We've started with a popular open source tool that we developed in-house called R10K. That's the first component of Code Manager. How R10K works is it takes a Git repository and it maps every branch that's in that repository to a configuration environment in Puppet Enterprise. So if I do a get branch-a here, you can see that I have two different branches, one for production and one for staging. What it does is when I run R10K on the Puppet master, it's going to look to this repository and take all of the contents of staging and put it into the staging environment in Puppet Enterprise, same for production. And if I had any other branches whatsoever, they could be named anything I like, it will have a corresponding environment in Puppet Enterprise as well. Now, how the content here, we're in the productions here. You'll notice if I do an ls on modules that the directory is actually empty. Why that is because R10K uses what's called a Puppet file to figure out what modules need to be populated into that configuration environment. So if I open up our Puppet file, what we're doing here is we're listing out all of the modules that we need for this environment. Here are the collections of Puppet Labs written modules that I pretty much inherently trust. And I'm going to specify each of the versions so that I can tie a version to a configuration environment and promote it as I see fit. We're going to use Jenkins to promote all of this. Now in community, here's some community modules that were written by community members that maybe I want to pay more attention to. I want to test a little bit more thoroughly, so I have those organized just a little bit differently. You can see here, though, that not only can you pull a module from the Forge, but you can actually also pull it straight from version control. So this module, this Jenkins module, I'm pulling straight from GitHub, and I'm tying it to a very specific commit. Down here at the bottom, this is where these are my in-house modules, my roles and profiles, and any other in-house modules that I would have written in order to manage my infrastructure. Now here, you'll notice I'm not referencing a commit. What this tells R10K is just get whatever master is. Get the latest commit and deploy that. What this allows us to do is run R10K in order. So run it in staging, and it will automatically pull down the master commit, whatever head is on master, for this profile module and the role module. Now, if I control when R10K is run, that means that I can control the continuous delivery of the latest commits to the roles and profiles into our environment. So let's take a look at how we're going to do that. If we go into our Puppet site job, we can go to Configure, and you can see that we have this script here. This is written using the Jenkins Enterprise Workflow plugin. It's a great plugin that allows you to specify a flow of tasks that need to happen and run certain tasks on different systems in your infrastructure, different test systems, in order to get work done. And I'll walk you through this really quickly. What we're going to do here is define a new stage called Deploy to Staging. And we're going to run R10K on the staging environment. And we're going to set a checkpoint that says staging deployed into Puppet Enterprise. And this checkpoint is really important. It means that we're going to do a couple of checkpoints throughout the script. And what it means is that if something happens, if something fails, but we know it's an intermittent failure for whatever reason, we can just pick up at the last checkpoint and take up from there, so that way we don't have to run through all of our tasks all over again. If you have a very large continuous integration process that takes several hours, that can be really important. So once we've done that, we've deployed, using R10K, we've deployed our changes to staging environment. We are going to run Puppet on a particular node. We're using mcollective for this. I was talking about mcollective earlier in the slides. Mcollective is a command and control system for Puppet Enterprise. What it allows you to do is run certain ad hoc tasks from the command line on a collection of system using filters. Now, over here, if we look at the run Puppet method, we are going to simply run MCO RPC service restart on the PE Puppet service. You can do this with any service. It doesn't have to be this service. Now, the reason I'm doing a service restart on PE Puppet is a lot of times when you do trigger a run of the Puppet agent, it can be in various states at the time. It can be disabled. It can be, it can be currently running. There's all these states you have to take care of. So the most surefire way to make sure that Puppet is run when you want it to be run is to simply kick the service. So that's what I'm going to do here. And then we're going to set up, and then we're going to, so we've run Puppet, and then we're going to run some deploy tests. Actually, we're up here. We're going to run some acceptance tests. Now, what we're going to do here, I'll show you this actual test in a minute, but we're going to check out our role module that has some acceptance tests, RSpec tests of its own. It's not using Beaker, but it's using some tests that we want to make sure that all of our profiles, when put together into one single role, all works together the way we expect it to. And we're going to use RSpec to do that. And then from there, we're going to deploy it out to production, run some post-deploy tests, and we're done. So normally, this process would be kicked off by another module test job. So if we went back here, if we look at this profile module job or any other module job, once it's done running Beaker and verifies that the change works, it would then kick off this Puppet site that would start that deployment process. But I'm going to go ahead and run it manually for the sake of this demo. So the first thing we're going to do is deploy to staging. We can see that we've got our first stage to do that. We can also pull up our console to see exactly what's happening. So here we're running R10K deploy on the staging environment. Now again, what that's doing is taking this branch in Git and running that Puppet file to deploy all of the modules that are specified in it to the staging environment, as well as all of our other content, such as our HIRA data. Now, earlier in the profile module, you saw me referring to HIRA. HIRA is a way of organizing data, separating your data from your logic. So you have your Puppet modules that knows how to actually do things on the system, that knows how to declare its state. But the data that feeds into that, such as where your database server is, your database passwords, things like that, maybe NTP servers, all of that data that kind of varies over time or through location, you'll want to put that into something like HIRA. If we go into our environment, you can see that we have two environments here that we're specifying. One staging, where I'm going to specify a WordPress DB user parameter that can be called from our Puppet modules that has a different user and password than the production system, which has an entirely set of credentials. Now, if you need RBAC around this, you can also look at our NC node service, our node classifier that is included in Puppet Enterprise, which allows you to have RBAC around how those classes and parameters are assigned to different nodes and who has access to see them and control them. So if we go back here, what we can see here is we've run our acceptance tests, and it's asking me a question. It's saying, are you ready to apply this to production? Now, what we can do here is, a lot of people think of continuous delivery as taking every change that you make and getting it out to production as absolutely quickly as you can. However, what I wanted to showcase here is this idea that that's not really what continuous delivery is about. What we want to do is prove that every change we make is deployable to production, but not necessarily deploy it until the business is ready. So this allows us to come back and say, all right, are we actually ready to deploy this change out? I know that the test passed because we got to this point, and we can actually go in and review it and see that they did, in fact, here we are. We ran a single test and we got 0 failures back. So we know that that works, and we can even go back and look at our staging environment and see that it does, in fact, function. Even better, if we go into Puppet Enterprise, we go into Event Inspector, which is a tool in Puppet Enterprise that allows you to see the different changes being made by Puppet throughout your infrastructure. We can see that we have this node here, WordPress Staging, which is our system that had a bunch of changes. We also had we can see that we can organize this by classes. So for example, if we come down here, we can look and see that we have this profile demo web that had a bunch of changes, and it was a bunch of changes happened to the WordPress staging. We can come in here and see everything that happened, including this service HTTPD was changed from running to stopped. If we go in and look at just all the changes that happened on WordPress staging, we can also see that Service Engine X was changed from stopped to running. So we know that this change applied correctly. This is exactly what we expected. So we can come back here and with confidence say, yep, apply that to production. So now that we've done that, what you'll see over here when we look at our console is we're going to merge staging into production, which we've done here, and we're going to push that back up to GitHub and then call R10K to deploy the new changes. All right, so now that that work is done, what had happened is it kicked off Puppet to run Puppet on production and then waited for Puppet to finish applying the changes to production before moving on to the next task. Once we finished running, you can see here it went down and ran acceptance tests to make sure that everything was functioning as correct as expected. We got 0 failures, and so our deployment was thus successful. I want to go ahead and show you just very quickly so you get an idea of what we're doing in our acceptance test when we're running tests against staging and production. What I'm doing is I have this one particular test in my acceptance directory called WordPress app spec. It's very similar to the test that we were showing earlier, except it just focuses on the behaviors of the application to make sure that the interactions, for example, that our customers would experience are functioning as our customers would expect. So we're not necessarily testing that Puppet applies correctly or that the database server is listening. We don't really care about that. What we care about is that the application functions as the customer will experience it. So in this example, since we're just deploying a simple WordPress application, all we're doing is doing an HTTP request against it, saying that we expect a 302 and we expect a redirect. If that happens, the application functions. Obviously, your application would have far more tests. You would be testing all kinds of behaviors, and it would take probably a lot longer. But it's important to try to make those types of acceptance tests something that you can run in staging and possibly even production, so that you know that all of your deployments go as expected and the application continues to function. So here we go. We've seen our full pipeline from beginning to end. We were able to do our local development on a single module. We were able to test it out. We were able to do peer review, even though it was just one of us today, and then do automated testing and automated deployment of that change from our VM to staging to production. So thank you for that.
All right, great. So now that we've seen how we actually can take all of these different technologies and piece them together and use them as a single toolbox to create a continuous delivery pipeline, I wanted to show that you can actually do this yourself. This is the code that I used to deploy all of the demo environment that you saw there, including the roles and profiles modules, as well as the site module that R10K used to deploy out all the modules and hire a data. And it also includes a Vagrant environment that you can spin up yourself. So we have 5 minutes here. Give me 1 second. My mouse has decided to freeze on me for some reason. Hey, Molly, will you go to the next slide for me? Computers. So a little bit about Puppet Labs. We were founded in 2005. We have millions and millions of systems deployed. We pretty much can go to any major enterprise now, and we're being used somewhere within that organization, somewhere within that company. We have a very large partner ecosystem. We partnered with a lot of networking gear as part of our Puppet supported program to be able to automate not just your compute servers, but also your network and storage devices as well. And we're making great strides there. We just partnered with EMC actually last week to become part of their Select program. Can you go ahead and go to the next slide? There we go. Thanks. We've got some really great customers we're very proud of and are doing some really great stuff with their technology, and I'll just kind of breeze through this. In the last 5 minutes, I wanted to go over some of the questions that were presented that you asked during the demo there. The first question is, how does monitoring fit into continuous delivery? I think it's a really good question because a lot of times when I go into IT shops and I talk to operations and I say, are you monitoring the application? They're like, yeah, we totally make sure that port 80 is up. Well, that's pretty useless, right? Like, who cares if port 80 is up? What you care about is that the application is functioning. When you ask a question of your API, do you get the expected results back? When you hit it with thousands of requests, does it hold up? Are you ready for that? For that massive rush of customers? In order to do that, you have to ask the same questions of your software that you do in staging and continuous integration during that cycle. So one of the things that I really, really love is not only making sure that you're monitoring the health of the individual systems, but you're using the acceptance tests that you write during continuous integration and run those as monitoring tests in production. Now, that's a little difficult. You probably cannot run all of your acceptance tests in production, but you'll at least be able to pick and choose certain ones that we can say that we can safely run those in production and continuously monitor the health of the system. The next question is, how do I audit what changes were made and by whom? Earlier I was talking about the importance of version control. I'm going to stress it again. Version control everything. Who approves of changes? That's a merge. Who merged that code? Who made comments on it? What were the conversations around that merge, around the pull request that was made? Let's look at the commits and understand who made what commit to what code base when and why. Version control gives you that. Version control gives you the audit process of who is making the approvals and who has access to that production code. So if you're in a SOX environment, one of the biggest pieces of the SOX environment is understanding the separation of responsibilities. Version control is a way to do that. Do that in Git, not in some change advisory board. And we have lots of data around this. If you check out our DevOps survey, it talks about this and the importance of having a peer review process rather than a change advisory council. We only have 1 minute left, so I'm going to go ahead and close off and thank everyone for your time. I hope you got a lot of benefit out of this. If you have any questions, be sure and contact sales, or you can contact me directly on Twitter, or it's pretty easy to find me on the internet. So yeah, thank you very much. If you can go to the last slide. Yeah, cool. All right, thank you.
All right. Yeah, that is all the time we have, but thank you very much. That's Carl Comm at Puppet Labs, and also Jeff Cogswell, software development expert, who took the time to share some information today about software development and ways to deal with the challenges of current business realities and current software development realities. So we hope you've enjoyed today's webcast. It will be available for on-demand viewing within the next 48 hours if you'd like to check it out again or you'd like to refer a friend. If you'd like to get more information about Puppet Labs, or if you'd like to download this presentation, you can use the Related Resources widget to the right of the viewing console. So once again, I'd like to thank our sponsor, Puppet Labs, and all of our presenters today. My name is Michael Steinhardt for CBS Interactive, and I hope everybody has a great day.